A partition of a set is a way to break it into non-overlapping parts. Let's define this properly. Suppose you have a set A. I will draw it as a rectangle here. And then imagine a collection of subsets of A. You have subsets A1, A2, AN. These subsets must follow three rules. First one, each subset is non-empty. So no subset in the partition can be empty. Rule number two, the subsets are pairwise disjoint. What does that mean? It means that no two subsets share any elements. AI intersection AJ equals the empty set if I is different than J. So for any I different than J, for example, A1 and A2, A1 and A3, A5 and A7, whatever, their intersection must be empty, so they don't share any elements. They are disjoint sets. And rule number three, the union of all subsets equals the original set. That is, A1 union A2 union AN equals A. What would that look like in a Venn diagram? Let's take a look at an example. Let's say that A equals the set of elements 1, 2, 3, 4, 5, and 6. One possible partition of the set A is the set of subsets 1, 2, 3, 4, and 5, 6. In the Venn diagram, this could look something like this, for example. Here we could have elements 1 and 2, here elements 3 and 4, and here elements 5 and 6. Let's check our three rules. Each subset is non-empty. Yeah, check. No subset here is empty. The subsets are disjoint, so there's no overlapping between them. This is also satisfied. You can see it easily in the Venn diagram. There is no overlapping between any subsets. And finally, the union of all subsets equals the original set. This is also true, right? We can see it in the Venn diagram that the union of all three subsets equals set A, and we can also see it down here. Together they cover all of A, so that's a valid partition. Of course, the partition could be a little different. So for instance, we could have the element 6 here. So another valid partition is 1 and 2, 3, 4, and 6, and the subset with the element 5. This is also a valid partition because it also satisfies all three rules. In computer science, an example of when partitions show up is when dividing data into groups. For example, clustering algorithms in machine learning partition data points, or when designing a hash table, the key space is partitioned into buckets. So it's a concept that you'll often see in computer science.